In the last video, we said that there were two series that you could actually find the sum. The first series was the geometric series, which is what the last video was about. And this series is about the second series where we can calculate the sum. This series is called the telescoping series. And the reason why this is called the telescoping series is that when we write out the nth partial sums, we will see that many of the terms cancel out in the middle. Many of the terms in the middle of the nth partial sum, Sn, cancel out. Okay, so it's kind of like a pirate's, telescope where, they extend it out and then they can collapse it and all the parts in the middle get collapsed. So it's kind of like a telescope. So here's our plan. We will calculate the nth partial sum Sn, and then we'll take a limit. That's going to be our strategy. Okay, so first, let's write out what our nth partial sum looks like. So in order to do that, I'm going to replace my indexing variable with an I so that we can go from 1 to n. And then that makes my general term I times I plus 1. So just to make sure we understand what it looks like, it's 1 over 1 times 2 plus 1 over 2 times 3 plus so on and so forth. And then the last term of our nth partial sum will be 1 over n times n plus 1. Okay. So I had mentioned a few moments ago that, a bunch of terms in the middle are going to cancel out. And you're probably thinking, how the hell does that happen? I only see, a bunch of things added together. Well, I think a key thing for us is we are going to use partial fraction decomposition for the inside there. Partial fraction decomposition. So we had done this in section 7.4 earlier, and we're going to do it again now. So let's do that. So I'm going to take my 1 over I times I plus 1, and I know that when I look at the denominator, this is distinct linear factors. So I know that I could split this up as some constant a over I plus some constant b over I plus 1, right? And when I put it under a common denominator, that's going to give me 1 over I times I plus 1. We're going to have a times I plus 1 plus b times I, all divided by the common denominator of I times I plus 1. So this means that I can just equate the numerators. So we know that 1 is equal to a times I plus 1 plus b times I. So I'm going to use the substitution trick. So when I is equal to 0, what does that tell us? That tells us that we got 1 is equal to a. When I is equal to -1, that tells us that 1 is equal to b times -1, which tells us that b is equal to -1. So writing out my partial fraction decomposition, we can see that we're going to get 1 over I times I plus 1 is really going to equal to 1 over I plus -1 over I plus 1. In fact, you could really write this as 1 over I minus 1 over I plus 1. And now you can see, oh, wow, introducing this negative here and the fact that the second term is, the denominator of the second term is exactly 1 more than the previous term, that is what's going to cause many of our terms to cancel out here. So let me highlight this partial fraction decomposition because this is key to the next step. Okay, so when I go to write my nth partial sum, Sn, what does that look like? Sn, like so. Well, what's the first term going to look like? The first term is going to be 1 over 1 minus 1 over 2. What's the second term going to look like? It's going to be 1 over 2 minus 1 over 3. What's the third term going to look like? It's going to be 1 over 3 minus 1 over 4. And so on and so forth, like so. What would the very last term look like? The very last term is going to look like 1 over n minus 1 over n plus 1, like so. Okay? And what do we notice happening? What we notice happening is that the first term of the next term, the first fraction of the next term is going to cancel with the last fraction of the previous term. So this 1/2 cancels out with the minus 1/2. This 1/3 cancels out with the minus 1/3, so on and so forth. The negative 1/4 is going to cancel out. The 1 over n is going to cancel out with the term that came right before that. And what are you going to get surviving at the end? What you get surviving at the end is 1 minus 1 over n plus 1. Okay? So now we know that our sum, S, the sum of the series, S is going to be equal to the limit as n goes to infinity of the nth partial sums. And this is going to equal to the limit as n goes to infinity of 1 minus 1 over n plus 1. Now as n goes to infinity, this second fraction is going to go to 0. So in the end, we get that our sum of our series is just 1. So this is just one example of a telescoping series. This is like the easiest, most straightforward to understand version. If we were to look at what other examples might include, well, when you do examples for homework, the partial fraction decomposition might look more complicated than what we got earlier. So you might have more than just one term surviving. You might have, several terms surviving. Or you might not do a partial fraction decomposition. Maybe you'll use law of logarithms to decompose it. All right, everyone. This concludes our video on telescoping series. Take care.